So it's like when you think about Lasso 9, it's very important to know what the lower code does, because you're going to read the Lasso talk list and somebody's going to post that. It'd be good to know, oh, that's a different way of writing a container tag. But if you're writing your own code, the upper example works just fine. It's like, and there's nothing deprecated or, it's like there's nothing wrong with it. But I want to show why, there's some very good reasons why we introduced this new syntax. And one of the big reasons is, this is a frequent feature request, people want members of data types to be able to be container tags. A good example of that is array for each, which is, it's a different way of doing an iterate, basically. So I wrote kind of code. We experimented with ideas like this over the years. How can we get a member tag to be a container tag? And what does the syntax for that look like? And it starts to look kind of silly. You can imagine different variants, perhaps. But how do you specify both the opening and the closing? I mean, you could leave my array off the closing. That might look all right, but it ends up being a bit confusing. So anyway, using the newer syntax at the top makes the operation pretty clear. We're going to assemble the code block. We're going to pass that code block in for each. It's going to be executed for each element in the array. It's like there's that makes a fair amount of sense. If you look at the string type in Lasso 9, it has a for each, which is for each character. It also has for each line. I don't remember what else, but it's able for each word. It's like it's able to do different amounts of granularity, and you can't really do that. It's like with the iterate tag, it's just one. It's one thing. So we could add an iterate line tag. We could add a bunch of things. But now we're getting further and further away from the string type, which is what knows what a line is. It knows what a word is. And so basically we want to be able to enclose this functionality in the string object itself. And like for each is one conceptual way that we can do that. So the new syntax really does have benefits for some things. But the container tags are still very much. You can do like an if using this syntax, but the else looks a bit weird because the else exists within the code block. So like for ifs, we recommend doing them just the way you would have in Lasso 8.5. Yeah, so here's, I'm going to talk about defining tags. And tags, of course, are central to Lasso. And I want to talk a little about what a tag is. And I think we finally, to some extent, I think we've been a little confused, probably in the documentation, about exactly what a tag is in Lasso. When we're all familiar with tags like field, returns the value of a field. And then there's an array tag, which returns an array, but that's also the name of a type in the language. So in Lasso 9, we're going to clarify exactly what a tag is. A tag it's something named in the language. And so there are a number of things a tag could be. Basically, when you call it, it will return a value. You can pass it parameters. But the tag could be a constant. It could represent an expression. It could represent a method, which is kind of conceptually what we tend to think of as a tag today. Or it could represent a type creator. And so the tag is actually the name of the thing. So in Lasso 8.5, we define tags using the define tag construct. We define types using the define type construct. We have also a define constant construct. In Lasso 9, all of those things are defining tags, and we simply use a define construct. So what it basically looks like is define my tag in parentheses with a signature, the association operator, which is the funny little arrow, and then the implementation, which is often in curly brackets. And again, we see though how similar this is to the container. This is similar to the container syntax, which is why I wanted to go through that first. Because here again, it's like the code block. We're not going to execute it right now. We're going to compile it, and we're going to pass it as an object to the thing on the other side of the association operator, which in this case is defining something. So we're associating the name with the code block. And then the code block is going to be executed later when we actually call the tag. So yeah, so my tag is the name of the tag being defined. The parentheses contain a signature, which will be a description of parameters. I'll talk about each of these elements later. And then just two more. The association operator is the little arrow, and the right-hand side I call the implementation of the tag. So we can, one example of defining a tag is defining a constant. I can define my constant to be 4.5. So at the bottom, if I call my constant in square brackets, I get back the result 4.5. No real execution is necessary. This is just an object that's been named for convenience. And then there's another example, pi. I could, if I want to set that to this value, then I call pi, get back this value. That's convenient. This next one is a challenge for my trigonometry, which I may have not remembered properly. But so constants are all very well and good, but we may want to name just a simple expression. So in this case, I'm going to name the expression 4.5 times 3.6. I don't want to do the math and figure out what that is. So when I call my expression, Lasso will do the math and give me back the answer. And those can be useful. You could use variables, page variables, and things in there. It doesn't have to be essentially a constant expression. I could define pi using, this may be completely wrong, but I could define pi using a trigonometric expression, so I get back a much better result for pi, rather than just hard coding a value. I can actually calculate the value of pi and get back what the computer thinks the value of pi is. But yeah, one thing to note here is that the expression is, it's not executed when this is run, it's actually executed when you call the tag. So when we do define my expression, Lasso isn't necessarily going to execute 4.5 times 3.6 right now. It's going to execute it when we later on actually call that tag. And in terms of optimization, I'm not sure. But so you might notice that that could be calculated in time. Yeah.
Do you have a way to checking if the expression is defined already?
It's Lasso tag exists.
Works.
Would work fine. There may be other ways to do it as well, but that would be one way. So, so these so far are basically constants and simple expressions, and so if we want to get into more of a method which actually does something and useful, I'm going to define my simple method, and here the signature finally is specified as x. So what I think of my simple method x as it's a template for how I'm going to call this tag in the future. And here I'm saying I'm going to call my tag and I want one parameter, and that parameter I'm going to call x. And I don't care what what type that parameter is. Then the implementation of this method is 4.5 times the local variable x. And I call it. It looks just like a tag call. My simple method 4.5 will give me 4.5 times 4.5. And basically, when you're using this expression syntax with no curly brackets, it's like the return is implied. We're going to get back the value. If I want to use a code block with curly brackets, then I need to use a return statement. So this is exactly the same method, but using a code block. Anytime, as your method gets more complex, if you want to use local variables and things, you generally will start to use this syntax. But this is exactly the same.